So we ended up asking this question, wouldn't it be great if we could tell how close we were to our goal? So we kind of ended with these couple of slides. So how can we tell if our search is getting closer to the goal? And the idea is that we would create a function called a heuristic. And a heuristic is a function that measures or approximates, that's probably a better word, approximates or estimates the remaining cost till we reach the goal. And so far, we've only thought about the cost of a plan in terms of the number of actions. So in this case, when we first see a heuristic, we're going to think about estimating the number of actions required to reach the goal. And if we look at this kind of puzzle-like environment, if we look at this puzzle-like environment, the number of actions correspond to the number of tiles that need to move. But of course, this is it's an approximation. If we knew exactly how many actions we needed to perform, we'd probably already know how to reach the goal. So instead of actually knowing that, we have to find a way to estimate or approximate. And here we can just look at the two states and say, well, how many tiles are out of place between our current state or our start state and our goal state? So in this case, there are 2 tiles out of place. And therefore, the distance to reach the goal, i.e. the number of actions to reach the goal, is at least 2. So we know those tiles have to move. So that means we have to perform at least 2 actions. We might have to perform more in certain cases. And this function that's returning an estimate of the distance to the goal is what we'll call a heuristic. And the heuristic is something which is calculated from the state information. So the heuristic is the distance to goal. And when we think about this in a search algorithm, we're going to apply this heuristic function, which we're going to call h, typically. We apply that to a state, and it gives us a number back. So this is what we wanted. This is a way of measuring how close we are to the goal. Sorry, I shouldn't say measuring. I should say estimating how close we are to the goal in our search algorithm. And it's really important to take away a couple of things from this. First, it is an estimate. Okay, this isn't the true distance, it's an estimate or an approximation. And the second thing that's important here is that a heuristic often needs domain-specific knowledge. So breadth-first search and depth-first search, for those algorithms, it doesn't matter what the problem is, they behave in the same way. So they expand the tree in the same way every time. That means they are general purpose or domain general or domain agnostic algorithms. They don't care about what the problem is. But when you write a heuristic, what you're generally doing is injecting domain-specific